Thank you. So welcome to the programming language of the future. My name is, as they said, I'm the first Robin. And I work at a consultancy in Oslo called Kodemaker. And yes, that is a Norwegian word. Got a lot of questions about that last night. My role there is as a full stack developer, and I'm contracted to companies in need of that. And when I'm not working for Kodemaker, I also work in a programming language called Gren. And if that rings a bell, it's because I had a presentation on Gren at HelloStavanger last year. But we're not going to talk about Gren today, or Kodemaker, or Norwegian words. There are other people who covers those kinds of things. Now, we're going to talk about some ideas I had last year when I was working on optimizing a single-page application for performance. You know, optimizing code is something we have to do on occasion, and there are some problems with it. And this entire slide kind of shows that I was given a lot of time to optimize this code. Usually you don't have time to philosophize, but I did. Now, the problem with optimizing code is, first of all, it can take a lot of time, right? You have to test things, you have to measure a lot, you have to come with hypotheses, and then you have to execute, of course, and hopefully the only thing you change is the execution speed, hopefully. But the reason why we tend to write unoptimized code first, or naive code, or simple code first, is because it's easier for us humans to understand. The first time you write the code, you're probably writing the first thing that comes to mind, and that's probably also the easiest code for someone else or your 6 months older self to read. So in optimizing code, you are in real danger of, yes, you're making the code faster, but you might also make the code harder to follow. And to make matters even worse, there usually aren't hints as to why code is written in a certain way, unless you're very good with documentation or comments. But in this particular case, the problem wasn't actually a single snippet of code, it was the architecture of the application. And so we had a whole section of the application that had to be written in a certain way in order to hit the performance targets that we wanted. And while I was doing this work, because re-architecting things take a lot of time, and all the while I was doing it, I was thinking, why do I have to do this at all, right? Why couldn't the computer, or the compiler really, why couldn't the compiler do this optimization work for me? And the answer is really quite self-explanatory when you think about it, and that's mainstream programming languages, really more than that, right? Most programming languages are not built in such a way that when you write down code, the compiler understands your intent. Right? Mainstream programming languages today are written to instruct the machine, instruction by instruction, on how it's supposed to compute something. It doesn't understand what you're trying to achieve, it only understands the tasks it's supposed to do and which way it's supposed to do it. And so, really, the compiler is not really given a lot of clues on how it can do the task you want it to do faster, because it doesn't know what you're intending to do to begin with. Another problem with this is that us as human beings, we're really bad at interpreting machine instructions. And if you think for a moment that that's not true, I'm good at interpreting machine instructions, then why do we need debuggers, right? We have written an entire suite of tools to run one instruction at a time in order for us to understand what really makes it work, right? There's too much state, there's too much code, it's hard to follow. So humans and machines fundamentally think in different terms, yet we are confined to use the same language, which originally, obviously we're working in higher level languages today than assembly, but that was the starting point, and we kind of like distilled languages from there. And those languages were never meant really for human consumption first and foremost. They were first designed for computers, right? How should the computer do the thing you want it to do? And this, the fact that we're confined to the same limited language is actually causing a lot of, not necessarily compromises, but it leaves a lot on the table, I think. So the first is that naive, simple implementation versus performance thing that I just talked about, right? The dumbest code is the easiest for us to learn, but it might be the most cumbersome code to execute for a computer. Another example of this is immutable data structures, which really kicked off from 2009 onwards when Rich Hickey created Clojure and created immutable data structures which were fast enough for general use. And the reason why these have become popular is because they don't change, right? You make modified copies, but the fundamental thing doesn't change. That leads to less moving parts in the system, less state for us to keep in our head. That's easier for us to reason about. But it's much more work for the computer to work with them, right? And that's the trade-off we've made for us instead of the computer. If you work in web frontends, which I do a lot of, state synchronization is something you do a lot of. And programming languages have no idea of what state synchronization is. Which makes sense, because when you're telling a computer what to do step by step, it's up to you to define state synchronization and to make sure that works correctly. But if you consider state synchronization from a human perspective, right, I can explain to someone what state synchronization is. When A changes, B changes as well, right? So natural language is better at explaining state synchronization than computer languages are. So we have to make sure to call the correct function after the given point, or create the right abstraction, or use the right library and use it consistently. The programming languages have no idea what this concept is. Resource management is another thing. Now, there are some languages who has this RAI principle. Resource acquisition is initialization. It's common in C++ and Rust, but it only goes so far, right? So if you were to do an HTTP request, and the reason for that HTTP request suddenly becomes invalid, right? So a user navigates onto a site, that should kick off, like, give me this data, but then the user realizes they did a mistake and navigates away. We're not canceling that request. You might, well, someone here might. But most programs that I work with don't. They let that finish, they let the backend do the work when it should have been canceled. Languages don't really help us in this regard. We as humans have to figure this out on our own. Dependency injection is also a common pattern we use, not because dependency injection in and of itself is a good thing, but it allows us some flexibility, right? It allows us to say, this is how the code should work, but in the exact context of a test, we want it to work slightly differently, right? We don't actually want you to touch the file system when doing a test. Just tell us what stuff you would have done, right? In that case is what dependency injection does for us. But it's also something the machine doesn't understand, and it's something we have to invent or create a framework to do. It's up to us, right? And so these sort of thoughts, and the reason I mentioned dependency injection and resource management and state synchronization and slow versus fast and readable code, right? It's because these are things that I encounter in every project. And languages don't really help us there. And so that makes me think that, maybe these languages, which are considered high level, in comparison to the old high-level languages, are these really low-level languages by today's standards? Right? We know what we want to do. The languages doesn't help us do it. Could we be better served with a higher-level language? And what would that look like? That's the million-dollar question, right? Could you invent a language which allows us to not focus on these things, or make those things embedded? Fortunately, someone has actually tried to make such a language, and it's called Eve. And it's a very fascinating language. The website is still up. I recommend you go to witheve.com later and just look at it, because it's a really fascinating language in many respects. This is the official Eve editor, and it's really just a markdown editor. Eve is a literal programming language, which means it's easier to write documentation and comments in Eve than it is to write code, which should give you some feelings, I guess. And then you have the program on the right side here, which is kept up to date as you're writing stuff. So these two are synchronized. The actual code in Eve looks like this. Not with the gray background, but the text. Horrible use of space here, but this is Eve code. Now, you might not understand the syntax. I'm just going to point out the things that immediately leapt out to me. There are no function calls here. None. There are no loops, explicit loops. There is a loop possibly happening here, though, right? These things are just not interesting because those are fundamentally low-level machine instructions. The thing that's interesting for us is the relationship between data here. So to explain what it does, we do a search for records. So in Eve, angle brackets are used for records instead of curly brackets. We do a search for records that has a name property. Right? And then for every one of those records, could be 0, could be 1, could be many, we are going to create a div in the browser DOM saying hello name. And this is a binding, so if at some point the number of records with a name changes, the divs are kept up to date. They're removed or altered as time goes by. Now, you can do things like this with React or whatever, but this is done at the language level. And that means that the language knows there's a direct correlation between records with a name and the divs you see on the screen, which is interesting. Now, if you've never heard of Eve, it's a shame, but it's also very understandable because Eve was developed by a company, and that company went bankrupt. Much to my annoyance. And no one really picked up, it's an open source language, but no one really picked it up and developed it further, which I think is a shame, because I really like the ideas here. So that was like last year for me. Like I optimized a single page application, and I was thinking about, there should be better ways to do this. And then the Christmas came, and I had to take a break. And so me and my extended family, we rented a cabin up in the mountains, and we went there. I put my kids to bed, and I sat on the couch, and my mom came with a glass of glögg, which for those of you who don't know is a traditional Christmas drink. It's like glue wine without the good parts. But they make up for it with sugar, so it's all right. And I sat there and I was thinking about, I was trying to relax, and I was sitting there, and then it occurred to me, glögg is the perfect name for a programming language, right? And you know the rule, like if you name it, you have to implement it. And and I just abide. So for the remainder of this talk, I'm going to show you glögg. Because next to a full-time job, being a parent, making a programming language, I still have some time to make another programming language, and I'm going to show you what that looks like. So obviously, we're going to explore the things that I've been leading up to something, and I'm going to show you how glögg solves those things. But when I'm going to create a new language for fun, send help. I also wanted to deal with two other things, right? Because making a programming language today, and if you think it's going to be successful, there are a couple of other things you need first, like users. But if we ignore those for a moment, people expect to have like a language server protocol or to have linting tools or formatters or whatever. So I wanted to see how can we make a language that makes building those things really easy as well. Is the idea. All right. Can everyone read the text there? People at the back? Excellent. Excellent. I can hardly read it, but so I have to develop it from the screen, but that's going to be all right. Okay, so we've created this wonderful project, or we created an empty folder, and we've installed glögg on our machines. So I guess I think the first thing we're going to do is to just install glögg. I haven't published it to NPM, so I'm going to do it from a local machine. So we're going to start with that. By the way, glögg is written in JavaScript, and it uses JavaScript-isms. But that's mostly just because that's the language I work most with, and that's the environment I'm most familiar with. This could have been implemented in everything else, and as I'm going to tell you later, and show you partly later, it can, in fact, very easily target another ecosystem. So we've installed glögg, and so we're going to set up a project. Now this, so we're going to ignore these things, just ignore those. But this is what happens when you run glg init. So it creates an app.glögg.db, and this is just a plain SQLite database. So I'm going to hook it up, and I'm going to show you. There's a schema and everything, right? And this is the first thing that glögg does differently from other programs. In glögg, you are not writing source code in text files. You are saving all your code in a SQLite database. And as good citizens, we're gonna start up Git, and whoop. Yeah. We're going to add that. We're going to be good citizens. We're going to commit this. Excellent. All right, so let's write some code. So obviously, I haven't written a visual editor for you guys, but I have, in the Glug compiler, there's an edit command. And what the edit command does is that it reads the database, creates a text representation for it, and saves it to a temporary file that we can open up in any editor. So this is Helix. This is my daily driver editor. And so I'm going to just do like the simplest program, the HelloStavanger program that everyone does as their first program. I'm not sure why I'm looking up there. So this is what the typical hello world looks like. We're going to do a commit, and a commit in this context means whatever follows the colon here, that is a known fact. These are the things we know. And so we're going to create a record. And this hash symbol here is really just the syntax sugar for a property called tag and the string. Because it turns out that tagging records is a common thing. So we have specialized syntax for it. And then we're going to add the HelloStavanger message. We're going to write and quit. That is going to update the database, which we can see here. So we can select from constraint value. Right, so here we go. We got two literals in our time program. That's log and HelloStavanger. So this really is just SQLite, and we're storing the code in a denormalized form. The interesting thing about this is what it enables. Right? So if you wanted to write a linter, or a review tool, or a refactoring tool, or a format, actually, you don't actually need a formatter because we're not storing white space at all. Right? But if you wanted to write any of those tools, you can pick whatever language you want, open up the SQLite database, and every language supports SQLite in some way. You can even do this in Bash, right? If you want to refactor something, you can write Bash script and modify the SQL. That also means if you want to target something else than JavaScript, you can write a .NET program that reads the SQLite file and spits out .NET assembly, and whoops, now you got Glug to .NET compatibility. But I know some of you are thinking, how is this going to work with source code, version control, right? Oh no. And this seems like something bad to give up, right? Version control. But it turns out Git is actually happy to learn new tricks. So when you create a new project, we have a command in the compiler that teaches Git a thing or two. So we run that, and then we run diff. And here we go. So we can have our cake. We can have our cake. So this works. Now, you might think that if you have a single file, it's a binary file, even if you can't diff it, that's not going to go well, right? You're going to store all these files together. But it turns out Git is actually very good at compressing files that look sort of the same. So this actually works out really well. And since we're denormalizing things, it doesn't take each commit doesn't take a lot of space either. Now, obviously, this is not going to work with GitHub PRs, right? But the fact that you can do this on a local machine means that if Glug were to become the next big thing, then it wouldn't be hard for GitHub to add support for it either. So that's not a problem. And of course, GLG edit creates, there's a canonical text format here. And you can imagine a world where you can tell Glug how you would like code to be formatted, right? And so you would always have correctly formatted code, and possibly even formatted according to the way you want to see it. And everyone can see code in the way they want to. But there's really no reason why you should limit yourself to text, right? People could create a visual editor that showed things visually. And as long as they write code in the correct way to the database, this should just work. All right, so let's make something. Well, actually, there's one more thing. So, okay, we're creating this record, and we can make it. That's another thing, by the way. Since things are stored in AST all the time, running make doesn't have to do parsing or any of that stuff. It just spits out JavaScript code. So compiling stuff is actually very fast as well. But anyway, running glg make spits out an app.js file, and when I execute that, nothing happens. Because all we have done, all we have done up to this point is just to create a record. It's the same as creating an object literal in JavaScript, although glug is free to represent this however it wants to. It can represent this as an array of 2 strings if it really likes. Or actually, a completely valid program is just an empty JS file, because this doesn't do anything. Glug knows this. Glug knows it doesn't do anything, and so when you compile it, it's actually free to just give you an empty file, because there is no direct relationship here between the program I write and the instructions the machine should execute. We've sort of outsourced the instructions to the compiler. That's not our concern anymore. But anyway, we want HelloStavanger to appear on the screen, so how can we do that? So in glug, every side effect, whether it's an HTTP request or writing to the screen or writing to a file, has to go through what is known as a context. So we're going to commit to the console context. And this isn't going to do anything. It's really just a way of saying, it's sort of like tables in a database or namespaces, right? We're writing the same record, but we're writing it to a console, whatever that is. To give that meaning, we're going to have to do. We're going to have to register an integration. So what we're saying here is that when anything that's written to the console context, we're going to send that data over to this JavaScript module. And that JavaScript module can take that data and do whatever it wants with it. So we're going to make it again. We're going to run it again. And there we go. Now, all right, so the thing about this, though, if you think about it for a moment, right? This means since we are adding integrations, I could now, without changing the source code, I could change what the console integration or the console context was aiming to. And I could have the exact same source code send that string to a server instead. And in fact, if we are to look at it for a bit, we can see there's an integration here called console. This is the module we're calling. And so this is just a function which receives a list of records, and then it does some things to figure out what to do with those. But I could have this do anything with those records. And I could change the integration with a simple binary call. So I could very, very easily say that, well, anything that goes to the console shouldn't do anything, or anything that goes to the console should keep a record of anything that's been written to it. So if I'm writing unit tests, for instance, I could say that, hey, all HTTP requests should be written to this table instead, and so at the end of the test, I can just read this table and see if you did the right thing. And so this is really a form of dependency injection built into the language. Let's do something a tiny bit more fancy. Let's create some ducks. So we're going to create, there's a duck called Scrooge. There's a duck called Donald, whose uncle is Scrooge. And then there are Huey, whose uncle, oh man, whose uncle is Donald. Then there is Louis and Dewey. I have no idea if I'm spelling that correctly. I apologize to any. Oh. Good. All right. So now we've created some ducks. And again, commits are facts. So these things exist. Again, I want to highlight that doesn't necessarily mean that those records will be created at runtime. Right? This is a human concept. Whether that actually exists at runtime is not, that is entirely up to the compiler. Right? So the compiler is free to omit those if it finds it it's not necessary to create those. And then instead of HelloStavanger, we're going to do a search for ducks, and we're going to take out their name, and we're gonna print to the console. Right? We're going to make it, we're going to run it, and there are all our ducks. Now, we're going to be a bit more fancy. So we're going to take out, we're going to find a duck. Then we're going to find the nephew, right? So first we're going to find a duck, we're going to take the name. Then we're going to find a duck whose uncle is that first duck we found. And then we are going to find the duck who has that uncle, or that duck as his uncle, whose uncle is that first duck. Then we're going to print that. No. Now, the question is, have I run into a compiler bug? No, all right, because it's ducky. And as you can see, this is a dynamically typed programming language. Is that right? Yeah. Here we go. This is known as the ancestor query. This is the logic language's version of Hello World. But you can see that we haven't written any loops. We haven't defined what to do if you can't find any ducks or anything like that. That would just terminate the query. So we don't have to define where these things are, how they look like, what data structures to use, how you write for loops, are you going to do dictionary lookups, anything, all of the actual execution here, that's entirely up to the compiler. The only thing you as a human have to worry about is the logical relationships between data. Excellent. Okay, let's do something even more fancy. We're now at, I got tons of time. Let's do something new. I don't need, whatever. We're going to install Glug. We're also going to install Vite and a plugin to Vite. I did both of the pronunciations just to be sure. I'm going to cheat a little bit. All right. So if you know Vite at all, there's nothing surprising here. We're simply doing the simplest Vite program that loads the Glug database, and we have a plugin that actually compiles JavaScript from that. I'm going to create a second thing here that just runs. Whoa. All right. Right. Oh, man. There we go. Yeah. Right. So we haven't done anything. This is an empty program, but we set it up. So let's write some code. We're going to do something simple. We're going to take a div. Child element is going to be HelloStavanger. This is going to commit. No. This is going to commit to the HTML context. And that itself is not going to do anything. We have to register the integration. There we go. And if we are lucky now, there we go. HelloStavanger. There we go. Right? And so that's interesting. So that's just something very, very simple. Let's make it more fancy. So I do a lot of work. I've contributed to Elm in the past, and so I have a very Elm-like mindset. So we're going to do the Elm counter demo. If you don't know what that is, it's going to blow your mind. I might have done myself a disfavor there. So we're going to create our state for a very, 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 very simple application. We're going to register an account. We're going to set that to 0. So this is our model. This is our state. And then we're going to do a new query. It's going to do a search for accounts, like that. And then we are going to commit that Yeah, and then we're going to commit that. And now it's 0, right? So that's nice. Then we're going to add some buttons. There we go. And now we want something to happen once those buttons click. So we're going to register an on-click thing, and when on-click is being clicked, we're going to send a message that we can easily identify here. Oop. There it is, yeah. We happy? Right. So now our registers and click handlers, nothing actually happens. So we have to, once those event occurs, we have to register, what to do with them. Again, this is also just another search. We're going to search the HTML database. So in the event of an on-click that equals, let's just do it simple first. Like that, just to print what happens. We're going to have to add the console integration for this to work. Right? So we got those. Let's make them do something interesting. So in the event of minus, we're going to do another search, because this does a search in the HTML context. This does a global search. For the count, we're going to extract the count, but we're also going to keep a reference to the record that contains the count. And then, instead of committing to the console, we are going to commit. No, we're going to commit to the global that from now on, the model count equals n minus 1. So when you click the minus button, that is going to change the global state so that count is reduced by 1. And since the state is reduced by 1, that's going to kick off our view again, which is going to update the view. I hope. Yep, there we go. Now, yeah, and for completeness, I'm going to do all this again, just with plus. There we go. And then I have a sneaky suspicion. So you can see that every time we change something here, it re-renders all the elements. And the reason for that is because we're using a commit. And this commit is saying, from now on, these things are true. What we wanted to do is something... What we wanted to do instead is to keep the things we have written already up to date. And that's not a commit, that's a bind. So a commit says, from now on, this is true, disregarding everything that's happened before, while a commit says, the things that I wrote before, keep them up to date because the search thing just changed, right? So synchronize them instead of overwrite them, essentially. I guess another way of saying is that commit is something that has, once the search has happened, the following will always be true, while a bind is saying that the search has, for the thing that's returned from the search, I want you to keep something up to date. So if this, then that, while a commit is, this happened, forever change this. So now, no way. All right, I got a bug here somewhere. Or it's a Vite thing. Oh, no. All right. Maybe it's because I don't have to make Vite sees that the database changed and then does the update. So this worked. You have to take my word for it. No, there we go. Yeah. Now it only changes the thing that actually changed. So the interesting thing, though, with this is that this doesn't use a virtual DOM, right? The programming language understands that once you click this button, that means that one of these three things are going to change. And it doesn't matter what hierarchical structure you have. It understands, click this thing over here is going to change. So you don't need a virtual DOM. The language gives you all the primitives you need to do the things that we do professionally. And that, of course, is going to be faster because yeah, you can do smarter things. So there are a couple of questions left because we're not using files. So we don't really have a way of structuring code. Everything is stored in a database, and you can imagine that once this thing grows to a certain size, that's going to be problematic. So Glug does give you a couple of things to kind of help you here. One of those things is that it has a visualization tool. So now I've written a diagram, and this yeah, I mean, this, like, yeah, fine, it's a it's a diagram of your application and how data flows between contexts, but this is too simple. Let's do something. If I can, let's bring back this, where we extract a count and we commit it to the console, just to have something to work with here, right? If we now visualize it, then you can see it's a little bit more interesting. But you can also, what else can we do? Let's do this thing. No, that's not interesting. Let's commit to my context. This is just dummy code to prove something to you. So if we do this, so now you get a little bit more information, right? So now you can see that the root context, which is just a simple @ symbol, communicates with the HTML context, and changes to the HTML context can trigger changes in the root. So these are intrinsically bound. And you can also see that changes in the root context can trigger a one-way data flow with console. And then you have my context, which is a lonely island. It doesn't affect the rest of your program, and the rest of your program doesn't affect it. So this effectively, potentially, is dead code. Right? But this allows you to get some sense over how the data relates to each other in your program at a higher level. We also allow you to limit the things that you want to search for. So if I only care about the data that might end up at the console, I can add this query at the end of edit here. And this will only give me the code of the application that has anything to do with that context. And so if you're looking for a special HTML view, you can do glg edit HTML, and you will only get view code. If you want to know why a certain thing ends up at the server, you can bring up that context as well. And I don't dare to show it to you because I think it will crash. But I also have a way of saying that, limit the amount of code to this subset, but also include anything that references those data structures. And so you could really, when you're editing code, you can really bring up all the stuff you're interested in and only that, and have that in a single view. And of course, this is the simplest thing I could do with the text editor. But if you were to build like an actual VS Code plugin, you could do a lot more fancy things, right? The only thing you need to do is to be able to read a SQLite file, and almost any language can do that. Right, so is this the future? I don't know. I think there are a lot of cool ideas here, but fundamentally, this is a research project. It's something I work on when I'm sick and tired of the other programming language I use as a hobby, right? So there are a bunch of things I just don't know here, right? So can we integrate types or schemas into this? I mean, maybe, I don't know. How does error handling work? You tell me, does this scale? in code size or in teams, I don't know, right? But what I do hope that you get away, the thing that I hope to have shown you is that there is a lot of innovation that can happen if we target humans instead of the machines with our programming languages. And I think, if any increase in productivity is going to happen in the next foreseeable future, it's going to come because we are exploring that space. So that's what I had. If you want to look at Glug, the source code is available here. You can download it, you can play with it, you can report bugs, but I'm not going to do anything about it. I work on this between too little time already, so progress is slow, but it's there if you want to take a look. If you want to look at the language that I honestly hope will become a mainstream language down the line, that's Gren. You can find it at the website there. It's sort of like a spiritual successor to Elm, if that tells you anything. So if you want to know more about that, there's the website. So yeah, thank you. That's all I had.